Linear functions. So we first want to define a linear function. It's pretty basic. It's a mathematical relationship, like we talked about in the prior section, that creates a line when graphed. So very familiar terms. This should all be reviewed. The slope of a line we refer to in a variable m is the ratio of its rise, which is the vertical change, to the corresponding run, which is the horizontal change. So again, you should be very familiar with this. We represent slope with the m. That is rise over run. This triangle, this is the Greek letter delta, which always means change. So we have delta y, or change in y, over delta x, change in x. Another way that we have written this in the past, very familiar formula, y2 minus y1 over x2 minus x1. So we can find the slope of any line if we are given 2 points by just subtracting the y values, putting that over the x values. So if we were to take this example, to find the slope of the line that passes through 2 points, we do not need to graph it. We can simply take those y values and subtract those. Remember, whatever order that you do on the top, you need to do the same order on the bottom. So then we would do in the same order that 4 minus that negative 2. And then we can solve simply 5 minus 3 rather, and 4 minus a negative 2, and you always want to reduce it. You typically will leave these in fraction form. There are some word problem cases where you'll see it as a decimal, but in a standard just writing an equation of a line, you're going to leave it as a fraction. Graphing lines. Now, we are all familiar with just plotting points. Graphing lines, just as a reminder, when it is in this format, the slope-intercept form, we can graph it using that 2. We always start on that y-axis, plot that 2. We can move using this slope. Remember, if we do not have a denominator there, it is 1. The top does represent the change in y. So the change in y means that we are going down 3 from that starting point. The denominator is the change in x, so we are going to the right 1. Remember, it can also be written as a positive 3 over a negative 1. That is the same thing, which means that we could move up 3 and then to the left 1, and you will see that all of those are on the same line. And then you are going to connect those with a line, making sure that you do have arrows on the top and the bottom indicating that is an infinite figure there. So again, some very familiar terms: slope-intercept form, y equals mx plus b, or now that we've discussed the function notation, you can have f of x equals mx plus b. Just as a reminder that m is your slope and that b is your y-intercept. And then you do have the general linear form. We've also called it the standard form, which is ax plus by equals c. And of course, a is greater than 0, or you would have a special case line there. So finding the y-intercept and finding the x-intercept is also pretty straightforward. When you're finding an intercept, you're going to set the other variable equal to 0. So if you're finding the x-intercept here, replace the y value with 0 and then simply solve for x. If you're finding the y-intercept, you replace the x with a 0 and you solve for y. Now when you have it in standard form or in the general form here, there is a shortcut, because anytime you replace the variable, in this case we replace the x with a 0, it zeroes this portion out. We just have ax equals c, and then to solve for x we would divide by a. So your x-intercept, when it is in this form, will always be c over a. Same thing is true for the y-intercept. When you zero out the x portion, you end up with just by equals c. So then to solve for y, you're going to divide both sides by b, and what the y-intercept will always be c over b. And so this is kind of a shortcut if you don't want to plug a 0 in and then solve every time. The other shortcut here is finding the slope. If you wanted to find the slope here, you can just change this from standard form to slope-intercept form. You would move this group that has the x, you would take that and you would move it over to the other side, which negates the number in front of x. And then you would divide everything by that b. And so when you get it in slope-intercept form, your slope will always end up being negative a over b. And so again, you can solve for it, you can move everything over, put it in slope-intercept form, or you can simply go straight from this and know that your slope is going to be the negative a over b, and the y-intercept is going to be c over b. And remember, the y-intercept is a coordinate, so that is why they have that written with the 0 there. So then how do we apply this? This says to find the intercepts, find the slope, and then graph the equation. And so when you look at this, you want to think about the fact that you have your a, you have your b, remember that b does include the negative, and you have your c. So if you wanted to find your x-intercept, that is just going to be your c value over the number in front of x, in this case 9 over 2. Remember, this is a point, so that is with the y value of 0. Your y-intercept is going to be c over the number in front of your y. And so in this case, it's going to be 9 over negative 3. You do want to reduce that. So this is going to be 0, negative 3. And then your slope is simply going to be negative a over b. So in this case, your slope is negative 2 over negative 3. And of course, again, you want to simplify that as well. So we've talked about the first two forms here. Again, both review. Slope-intercept form, y equals mx plus b. The general form, or the standard form, ax plus by equals c. And then the next form that we use a lot is going to be the point-slope form. And so this is often used when we have just the slope and a point, or we have 2 points and we need to solve for the equation of the line, like this next example. It says, write the slope-intercept form equation of the line passing through these 2 points. So the first thing we want to do is we want to solve for our slope. We're going to do that using our slope equation. And so this is going to be our y's on top and our x's on bottom. In this case, 7 over negative 2, or negative 7 halves. Once we have our slope, we want to then put it in slope-intercept form as we have been instructed. So we can choose either point to do this, and we are going to use our point-slope formula as well. So our point-slope formula looks like this. You'll notice that if we were to write an m for our slope and just multiply this across, we would get our slope-intercept form. That's where it comes from. And so our point slope just comes from our slope equation. Take either of the 2 points. We're going to choose this first one, 1 and 6. And then we have solved for our slope, and we're just going to plug those in. Y minus my y value of 6 equals m times x minus my x value of 1. We can then distribute to simplify this. And then, of course, we are going to do the final step, which is moving that 6 over. Remember, this needs a common denominator. So we're going to say 7 halves plus 12 halves. 12 halves is just 6 with the common denominator. That gives us 19 halves. And so our equation looks like this. We have our y by itself equals mx plus b. And that is our slope-intercept form of this equation, using our point slope and moving it over to be in slope-intercept. Just a couple of special cases here. When you have x equals a number or y equals a number, you have special cases. So this is y equals -3. Anytime you have y equals a number and you do not have an x in your equation, your slope is going to be 0. The alternative to that is having a vertical line, and you end up with all rise and you don't go left or right. It looks like this. In this case, x equals -3. You have just an x with no y, and you have an undefined slope here. So vertical lines and horizontal lines are special cases. Some more review of lines would be parallel and perpendicular lines. So when we have two lines that are parallel, then that means that they are going to have equal slopes. So anytime you have parallel lines, you will have equal slopes. This means the first slope is equal to the second slope. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So when you multiply their slopes, you get -1. Another way to say this is that they are negative reciprocals of each other. Anytime you multiply a number and its negative reciprocal, you will get -1. So that is why we like to also refer to it as negative reciprocals, because when you multiply those slopes, you will get -1. It's a quick way to check to see whether or not you have parallel or perpendicular lines. And so if you want to write an equation and you have been given an equation and they want something parallel or perpendicular to it, you are going to use the slope. So this is in standard or general form. We need the slope, and we're going to use that little shortcut there. -a over b is this slope. Well, they want us to get a line that is parallel to that line, so we need to use the same slope. And we can once again use our point slope equation. Y minus y1 equals m times x minus x1. And we can now just plug it in. We have our y value, y minus y1. We have our slope, -2/3. And we have x minus our x1 value. Simplify it, minus a negative. Same thing over here, minus a negative. And then we can distribute and solve. Simplify by moving that 1 over. Remember, 1 with a common denominator here is going to be 3 over 3. So we have y equals -2/3 x minus 7/3. That is parallel. We can do the same thing with perpendicular. In this case, they gave it to us in slope-intercept form. The original slope was 3/4. So if we want a line that is perpendicular, we're going to flip that upside down and we are going to change the sign. It was positive 3/4. It is now negative 4/3. And so this is the slope we're going to use for this line. And we are going to do exactly the same thing. We don't have to go through the entire process, but we would say y minus my y value equals my new m, since this is perpendicular. And we would do the same exact process. We would distribute, simplify this, and move the 2 over. So go ahead and finish that problem. The last two things we're going to discuss in this section are the distance formula and the midpoint formula. You do need to memorize these. You need to be very familiar with them, as you probably are. Your distance is just the square root of the difference between your x's squared plus the difference between your y's squared. So you're going to subtract those x's and square it, subtract the y's and square it. And the midpoint formula, you just basically average each value. Average your x's, average your y's. So if we wanted to find the length of the midpoint, we would just plug those in. If I wanted the length, that's the same thing as distance. We would subtract those x's and square them, and subtract those y's and square them. And then you're just doing basic simplifying here. If it does not have a perfect root, you can just leave it as a radical. For midpoint, it's even easier. Your midpoint is just going to take those x's, add them up, and divide by 2. Take those y's and add them up and divide by 2. It is a midpoint, which means you have an x and a y. And so you do want to simplify those as much as possible, but it is left in XY form as it is a point. So just as a review, so that you have a summary of all of your equations in one place, we do have forms of linear equations. We have the general form of an equation, or standard form of equation, which is ax plus by equals c. We have our point slope, which is y minus y1 equals m times x minus x1. And then we have our slope intercept, which is probably the most familiar, y equals mx plus b. For slope formulas, we have the basic definition of slope, which is your y2 minus y1 over x2 minus x1. You have your parallel lines, which means your slopes are equal. And then you have your perpendicular lines, which are negative reciprocals of each other for those slopes.